Okay guys, so today we're going to be talking about graphing quadratic functions. It's also our introduction to quadratic functions. And a quadratic function in general form looks like our blue box here, which is y equals ax squared plus bx plus c. Okay, where if x squared is the highest power on x, we're going to have a quadratic function. Okay, so its graph, you might remember this. You've probably seen it before back in Algebra 1. The name of the shape of the graph here, this U shape, is called a parabola. There's some parts that are important on our parabola. One of them being kind of the maximum or minimum. In this case, it's the minimum y value on my graph down here is our vertex, which is located at hk. And this is normally be like x and y, but we already have an x and y used in our equation, so we're using h and k for the x and y coordinates of the vertex. Then we have this point, or this line, I should say, sorry, that comes through the middle called the axis of symmetry. Okay, our graph is symmetric, as if you were to reflect one half of our graph over that line, it would go on top of the other half. So it's an axis of symmetry, and that's located at the equation x equals h. Okay, so in our general form, it's not easy from the equation to tell where that vertex would be, that lowest point. Okay, one of the ways to calculate our vertex is we have a formula here. To get the vertex, h, which is the same thing as the x coordinate of our vertex, is equal to the opposite of b, so negative b, all divided by, I should say, 2 times a. So negative b, or opposite of b, all divided by 2a. Okay, the y coordinate we can get, so in this case k, which is the y coordinate of my vertex, we can get by plugging h into our quadratic. Okay, so we can use this formula to get the x coordinate of our vertex, or this is like x, and then we can plug that value into our function for x to get y. Okay, so this gives me the x coordinate of my vertex, this gives me the y coordinate of my vertex. Okay, there is another form that we commonly see quadratics, which is called vertex form. Okay, vertex form is very nice because, as the name sounds, it gives us the location of the vertex just by looking at the equation. So we don't have to do the opposite of b over 2a and plug back in. We can actually identify them from these h and k values here. Okay, where this h value is going to give me the x coordinate of the vertex, and k out here gives me the y. Now, one part that can throw some trouble in here, though, is that it is x minus h. So, in other words, if you see something like this, x minus 4, let's say in that part, h is actually positive 4. The minus is part of the formula there. So there, h would equal positive 4. If you were to have something like x plus 2 squared, here h is actually negative 2. You could actually even think of this as being x minus negative 2. So that's our minus h. So here h would be negative 2. Okay, so a mental shortcut that might help is that h is kind of the opposite of sign of what it appears to be, and then k is the same. We don't have to do anything special for k there to identify our vertex. Okay, so let's try some examples here. It says, find the vertex and the equation of the axis of symmetry for each of the following. So our first one, I noticed that this is in the vertex form. They've given me this nice form with h and k visible, so this should help me find our vertex pretty easily here. Okay, so remember that we're looking here to get h in our quantity squared, but h is the one that's kind of the opposite of what it appears to be. So here h is actually negative 4. Okay, and our k value is whatever after our quantity squared that's being held with addition or subtraction. So in this case, negative 6. So k is negative 6. Okay, so our vertex is located at negative 4, negative 6. And the axis of symmetry, which we'll use AOS, is this vertical line x equals our h value. Since our h value is negative 4, that's what we put. So there it is. There's my vertex. There's my axis of symmetry. And that is an equation. So please write x equals negative 4, not just negative 4. It's not a single value. It's an equation of that vertical line, x equals -4. Okay, let's try our next example. For number 2, I notice this time our equation's given to us in general form. So we can't immediately identify that vertex. We're going to have to solve for it using these formulas that we saw in the middle here. So let's start by doing that. Let's find h, which is equal to the opposite of b over 2a. Okay, and in this case, this is our a value. Our a value is 2. Our b value is -12. And our c value is +24. Okay, so remember that it's opposite of b, so the opposite of -12 is +12 over 2 times a, so 2 times 2, our a value is 2. So we get 12 over 4, which gives us 3. My h value is 3. Okay, to find k, the y-coordinate, we need to plug in 3 into our function. So we need to find, so we're going to say k equals f of 3. So plug 3 into our function. 2 times 3, 3 squared minus 12 times 3 plus 24. So again, order of operations, remember exponents before you multiply. So we're going to have 3 squared, which is 9. It's a 9 there. Minus 12 times 3 plus 24. Now we can multiply 2 times 9 is 18. -12 times 3 is -36 plus 24. 18 minus 36 is -18 plus 24 is +6. Okay, so I didn't leave myself a whole lot of room here, so maybe I'll just try to squeeze in over here. We do have a third example to get in here. So my h value ended up being 3. My k value, which we just solved for, is 6. So I know my vertex is located at 3, 6. And my axis of symmetry is located at x equals h. And our h value was, that's not a 3. X equals 3, there we go, our h value. Okay, so these are the two forms that we saw earlier. I've just written them here for easier access. Okay, so we have our standard form over here, our vertex form, quadratic over here. Okay, so it's important to know that the a in front of both of these is the same value of a. Okay, if that a value is negative, our graph is going to be flipped upside down. Okay, we would say our normal U-shaped graph opens upwards, that parabola, and if a is negative, it would open upside down. We'd say it opens downwards. Okay, but we'll see a lot throughout the year, and it will mean our graph is flipped upside down. Okay. If the absolute value of a is greater than 1, meaning if we have any values like 2 or -2, 3 or -3, so regardless of its sign, whether it's positive or negative, if the digit is bigger than 1, okay, our graph will be vertically stretched. If my normal graph looked something like this, and my a value was 2, it would look a little thinner. It would look like it's been stretched vertically. So imagine pulling something that would stretch in the vertical direction. Okay, if, however, a is a value that falls between 0 and 1, so this happens with decimals that are between 0 and 1, or fraction values like 1/2 or -1/4. And again, we're talking about its absolute value, so it could be positive or negative. Remember, that only controls whether it opens up or down, the positive or negative sign. But if its value falls between 0 and 1, our graph will be vertically compressed. So imagine taking a graph that looked like this, and we kind of compressed it in the vertical direction. It ends up looking a little wider. Okay, so it'll look wider than our parent function. This really only applies to our version that has h and k in it right now, but we can talk about those from the origin, from our parent function. H is going to shift my graph left or right, and k is going to shift my graph up or down. And we'll see those a, h, and k show up in a lot of functions throughout the year. So we're just introducing it now with parabolas, but we will see those a lot. So it's important to know a is negative, it flips my graph upside down. If a, regardless of its sign, if the digit's bigger than 1, we get a vertical stretch. Okay. If A is between 0 and 1, we get a vertical compression, which makes it look a little wider. H will shift my graph left or right, and K will shift my graph up or down. All right, well, let's do some examples. Identify the vertex, axis of symmetry, transformations, domain and range, and then graph each. So it definitely sounds like a lot of stuff, but we've talked about a lot of this already. Okay, so the first thing we want to identify is which form of the equation we were given. So it looks like for example 3 here, that this is in that form, the A, H, and K, called vertex form. Right. So it's in that similar form. We should hopefully recognize it because it's got that big quantity squared here. So let's first go ahead and identify A, H, and K. Okay, so my values of A, here in front, my multiplier is a positive 1, so A is 1. My H value, remember, is inside of here, and this is the one that is the opposite of what it looks like. So here H is actually negative 1. And then K, which is added or subtracted afterwards, is negative 4. There's no tricks with K. So my vertex is located at the coordinates H, K. That's the X and Y coordinate of my vertex. Okay, so that's going to be the highest or lowest point on my graph. So we've got the vertex there. Next, let's find the axis of symmetry. So the axis of symmetry is the equation X equals H, which in this case is the X coordinate of our vertex, negative 1. Okay, we'll go ahead and talk about the transformations next. So first thing I like to look at is A. Since my A value is positive 1, positive means it's opening up, so that's like our standard parabola. 1 means it is not stretched or compressed. It's actually the same as our standard parabola. But we do have some shifting going on here with H and K. So H is our horizontal shift, and an H value of negative 1 is a shift left 1. So we'll use L1, so left 1. And my K value is my vertical shift, and a negative number means down. So we've been shifted down 4. Okay, so let's go ahead and start graphing this. So those are my only transformations this time, as I shift left 1, down 4. Okay, so let's graph it. We'll do the domain and range at the end. So let's start with our vertex. So we were given our point, negative 1, negative 4. And we're going to fill in kind of our t-chart here. Negative 1, negative 4. So we're going to go left 1, down 4. 1, 2, 3, 4. Negative 1, negative 4. There's my vertex. Okay, so we're also going to graph in our axis of symmetry, and that is the vertical line where x is negative 1. Fortunately, it's a lot of my axes numbers are, but there's my axis of symmetry. X equals negative 1. Okay, so when I find points on the left or right of it, we can use symmetry to fill them in. So for instance, if there was a point here, we could use symmetry to find point, 2 units to the right, then 2 units to the left. There should be a symmetric point. Okay, I don't know where those points are yet, but that's how the axis of symmetry will help us. So I like to put my vertex right in the middle of my t-chart, and personal preference, I like to circle it. And then we're going to pick some x values around it. So if I were to go up, we'd have 0 and 1. If we were going to go down to negative 2, negative 3. So we're picking them directly to the right and left of our vertex, these x values. Negative 2, negative 3, 0, and 1. Okay, because we know they should hopefully fit in our graphing window. So then what we need to do to find our y value is substitute in. So we're going to come back up to our equation here, and we're going to substitute in. Now, I want to pick values that I think will be easy to plug in. And keep in mind that negative 2 and 0 will actually give us symmetric points. So whatever answer I get for 0 is going to be the same as negative 2. So I can pick one, like plug one in or the other, but I should get the same answer both times. So we're just going to plug in 0 here. So rather than f of x, I'm going to do y. We're going to plug in 0 for x. 0 plus 1 squared minus 4. So order of operations, we simplify in the parentheses. Then we would do our exponent. 1 squared is 1. And then add or subtract. We would next multiply if there was an a value out here, something other than, positive 1. But in this case, there's not. So we just add and subtract, and we get back negative 3. Okay, so 0 is at negative 3. Okay, which means negative 2 is also at negative 3. Remember, we'll have that symmetric point. Okay, well, I can plug in either negative 3 or positive 1. They should both give me back the same solution. I'm going to plug in positive 1. So we have 1 plus 1 squared minus 4. Simplifying in the parentheses, we get 2 squared, which is 4. Right, exponents next. And then, 4 minus 4 gives us back 0. So in fact, the point 1, 0. So write 1 up or down 0. And my symmetric point over here, negative 3, 0, is also a point on my graph. And now I can sketch in my parabola that starts to curve upwards. The standard rate of our parabola has a lowest point, in this case down here, of negative 4. Say our minimum value is negative 4 because y is the minimum value. Last thing to do in here, let's do our domain and range. Okay, so remember that domain are our possible x values. So my domain, this graph does continue left and right forever, and there are no gaps or holes. We'd say our domain is all reals, all real numbers. Okay, for our range, which are possible y values, now my graph does go up forever, but it does not go down forever. In fact, we have a lowest value here. So I'd have to say that all my y values need to stay above or equal to that y value. The way we'd say that is with our inequality. It needs to stay greater than or equal to the y coordinate here, which is negative 4. So there's my domain and range. Okay, let's move on to number 4. And we went a little slow with that one. So this one is also in vertex form. Here, this time my a value is negative 2. Okay, my h value is positive 4. Remember, this is the one that's the opposite of what it looks like. And my k value is positive 2. Okay, so let's identify our vertex here. That means my vertex is located at hk, 4, 2. And my axis of symmetry is the line x equals 4. Okay, next let's talk about our transformations. So my a value of negative 2, first of all, it being negative, as it is flipped upside down. The 2 is actually a vertical stretch by a factor of 2, meaning it's going to be twice as tall, so it's going to look thinner than the parent function. And then it's also been shifted right 4, that's the h value of positive 4, so that's our left to right movement, positive means right. And then k, our vertical shift, positive 2 means up. So right 4, up 2. Okay, so as we go to graph this, we'll start with our vertex, which is at 4, 2, right 4, up 2. Okay, we'll put that in our t-chart here as well, positive 4, positive 2. Okay, and of course, we'll pick some x values around that, like 5 and 6, 3 and 2. We'll draw in our axis of symmetry at x equals 4. Okay, so axis of symmetry, x equals 4. It's pretty sloppy there, but we'll go with it, x equals 4. All right, let's find some new points. So once again, we're going to plug in. So I notice that the first operation I'm doing up here is subtracting 4. So I actually think 5 and 6 are going to work out better because I won't get a negative number. I don't know, it's about the same. Again, if I plug in 5, I should get the same answer I would if I plug in 3. And when I plug in 6, it should give me the same answer I would if I got 2. Okay, so I'm going to plug in 5 here. Negative 2 times 5 minus 4 squared plus 2. So parentheses first, 5 minus 4 is 1. Then our exponent, 1 squared is 1. Now multiply, negative 2 times 1 is negative 2. And adding, we get 0. So 5, 0. And our symmetric point 3, 0 is also on our graph. Okay, I'm going to plug in 6 for our second point. Negative 2 times 6 minus 4 squared plus 2. Okay, 6 minus 4 is 2, so simplifying the parentheses. Next is our exponent. 2 squared becomes 4. Negative 2 times 4 as we multiply is negative 8, plus 2 is negative 6. So 6 is down at negative 6 right here. And 2 would also be down at negative 6. And this makes sense. We said our graph should be opening upside down. It is. It's vertically stretched, so it'll look a little thinner than our parent function if it was flipped upside down and shifted right 4 and up 2. All right, let's try a couple more examples. We'll go a little bit quicker. Wait, let me do the domain and range. Let's not forget about that. Our domain, once again, is all real numbers, and that's actually true for all parabolas here, at least that open up and down. Okay, my range, though, this time my y values don't go up forever. They do continue down forever, but they have a highest point here that they can be, which is at 2. So all my y values need to be less than or equal to 2. Last thing before moving on, just to talk about that when we're solving equations, if I set this thing equal to 0 and we solved for x, the zeros are the same as our x-intercepts. So the roots or solutions here would be negative 3 and positive 1. The x-intercepts are our solutions when we set our equation equal to 0, as well as positive 3 and positive 5 for this graph. Okay, now these next two are going to be a little more difficult because these are in standard form. Now, the one extra piece we can get from standard form, that's this form, ax squared plus bx plus c. We don't get the vertex right away, but c in standard form does give us the y-intercept. So I know that, for instance, at positive 6, my graph should cross the y-axis. So I do get kind of one free point here on my graph, but other than that, we can identify A, so if it's been flipped upside down or stretched or compressed, but we don't know the vertex right away. So let's first start going through and finding our vertex, and we had a formula for that. We use the opposite of B divided by 2 times A. This is going to give me the x-coordinate of our vertex. So here's B, positive 8. The opposite of that would be negative 8 over 2 times A, and my A value is 2. So we get negative 8 over 4, which is negative 2. So the x-coordinate of my vertex is negative 2. Okay, to find y, we need to substitute 2 in. So we go back to our equation here. 2 times x squared plus 8 times x plus 6. And we're going to substitute in the negative 2. Okay, so order of operations, we would do our exponent first. Negative 2 squared is positive 4. Okay, and then we can come back and do all of our multiplying. 2 times 4 is 8. 8 times negative 2 is negative 16 plus 6. 8 and negative 16 make negative 8. And negative 8 plus 6 is negative 2. So negative 2 happens to also be the y-coordinate of our vertex. So our vertex here should be at negative 2, negative 2. Our axis of symmetry, remember, as always has to do with the x-coordinate of our vertex. So the axis of symmetry is the line x equals negative 2. Okay, so we'll go ahead and plot in our vertex, negative 2, negative 2. So it'll be down here. And I've got my axis of symmetry, x equals negative 2, running right through here. All right, as far as transformations, we could talk about our shifts for our vertex. We've gone left 2, down 2. As far as our shifts, my A value here is a 2. And since A is 2, it has not been flipped over, right, because it's still positive, but it has been stretched. So we have a vertical stretch. by a factor of 2. That'll make it look a little bit thinner. And as far as our shifts, we can use our coordinates of our vertex. From the origin, we've gone left 2, down 2. So shift left 2, down 2. All right, so as far as points for my t-chart, we'll pick a couple points as we get larger, -1 and 0. And as we get smaller, -3, -4. And if we went big brain on this, we might notice that, wait a second, when I plug in 0 for x, I actually already know the point there. It's at 6. That was given to me by my y-intercept way back up here. So saving myself a little effort and using symmetry, I get another point on my graph, the symmetric one on the other side of my axis of symmetry here. It's cool. So I really just need to plug in either -3 or -1. Let's go with -1. I think that'll make my life easier here. So 2 times -1 squared plus 8 times -1 plus 6. Order of operations, exponent first. That becomes +1. -1 times itself twice. Multiplying 2 times 1 is 2. 8 times -1 is -8 plus 6. 2 and -8 make -6 plus 6 is 0. We get a y value of 0. So we have -1, 0 right there, and -3, 0, the symmetric point. And there we go. My graph's opening up. It's been vertically stretched by a factor of 2. It's been shifted left 2, down 2 from the origin. I missed my point a little bit, but you know, good enough for a tablet hand sketch here. And if we set this thing equal to 0 and solved, by the way, if you did that, you say, I don't know, factored out your 2 and did your factors. So if you factored out a 2, it's x squared plus 4x plus 3. Oh my gosh, that x factors so nicely. So if you set your equation equal to 0, that's x plus 1 and x plus 3. And you set each one of those equal to 0, you get x equals -1 and -3. And guess where it's crossing? At -1 and -3. Okay, now you weren't asked to do that, but I'm just pointing out that these are the solutions. If we set our equation equal to 0 and solved for x, it is the x-intercepts for my graph. Okay, let's try one more of these. The first thing I notice over here is I don't have a constant in my standard form, which tells me my y-intercept is 0. So it's crossing at the origin. Let's see, my a value would be -1, so it is flipped upside down. But let's find where our vertex is. We're going to use our opposite of b over 2a. So opposite of b over 2a gets me the x-coordinate. So in this case, this is our b value. The opposite of -4 is +4. Over 2 times a, which is the -1 hiding in front of our x squared there. So we get 4 over -2, or -2. Okay, once again, our vertex has an x-coordinate of -2. So let's plug that in to find y. We're going to have -x squared minus 4 times x. And then we don't really need the +0, do we? And let's plug in our -2. Now, be careful here with your order of operations. -2 squared first, and then we're going to apply this -1 out front, or multiply that -1. Okay, so -2 times itself twice is +4, but this negative sign is still out front. And now we'll go back through, well, I don't know what happened to my 4 there. Now we'll go back through and multiply. -1 times 4 is -4. -4 times -2 is +8. And when I add those two together, -4 and +8 make +4. Our vertex is at -2, +4. That means my axis of symmetry is the line x equals -2. Remember, again, it has to do with the x-coordinate here. And we can plug that into our t-chart here. -2, 4. And picking some points around this. So -2, +4, here's my vertex, left 2 up 4. And we'll draw on our axis of symmetry. Okay, and in fact, we already have one free point, and we can put that symmetric one over here as well. But Let's identify some points around this. As we were to go up, this would be -1 and 0. If we were to go down, -3 and -4. And in fact, we already know 0, 0 is a point that was given from our y-intercept. And that means the symmetric point, oops, I'll have to redraw that in. Our symmetric point here would also be -4, 0. So I really just need to plug in 1 again, which is kind of nice. Let's plug in -1. I could do -3 or -1. They should give us the same solution. Let's do -1 squared minus 4 times -1. Ooh, goodness, -1. Okay, so -1 squared becomes +1. Exponent first, now we can multiply. -1 times 1 is -1. -4 times -1 is +4. And adding, we get 3. So -3 is up at 3. And -1 is also at 3. And so here's my graph, which is flipped upside down. We'll need to talk about our transformations, which we haven't done yet. Okay, so based on my a value here of being -1, it has not been stretched or compressed, but it has been flipped upside down. And based on my vertex, we've been shifted left 2 and up 4. So shift left 2, up 4. And again, it has not been stretched or compressed because that digit is a 1. Right? The negative part just tells us it's flipped upside down. Lastly, our domain and range, which I guess we haven't done for either of these, so let's do that quickly. We know the domain on both of them is all real numbers. So we'll go ahead and write that for both, all reals. Okay, it goes left and right forever with no gaps or holes. But our range will be slightly different. So this graph does continue up, but this is the lowest point I can have. So it is allowed to equal -2, but it has to get bigger from there. So greater than or equal to -2. Whereas this graph is only continuing down forever, and it has a highest point or maximum. So here my range is that y has to be less than or equal to 4. Okay, so last, let's end with a word problem here that will have to do with our lesson today, and quadratics and parabolas. It says the profit from selling tickets at the Smith Center depends on the ticket price. Using past receipts, the owners have found that the profit can be modeled by this function. P of x equals -15x squared plus 600 times x plus 60, where x is the price of each ticket. Okay, so they just defined x for us. What is the ticket price? Ooh, if x is the price of each ticket, what is the ticket price? So they're basically asking me, what is x? That yields the maximum profit. Okay, well, profit is modeled by this function, so P of x that yields the maximum P of x or a y value. So what is the ticket price? What is the x value that yields the maximum profit or y value? So let's use what we talked about today to think about some things about our graph. Okay, so remember that this a value is the same in both forms, even though this quadratic is in our standard form with a, b, and c. But our a value is -15. So we know a couple things about my graph from there. Negative means it's been flipped upside down over its vertex. And the -15 means it's very, very stretched. It's like super stretched in the vertical direction. Probably even thinner than that. You might have imagined we're really zoomed out here. Okay, so it's an upside down graph. And we're graphing, of course, if these were our coordinates. It doesn't matter exactly where they're at here. But x is our ticket price. Whoops, I don't know what happened there. Price, okay? And then our y value is our profit. Okay. So what is the ticket price that yields the maximum profit? Well, if my profit is my y value, the maximum profit is going to end up being at our vertex. So we need to find the x coordinate of our vertex, which has to do with the price, and the y value, which has to do with the profit. Price, which is x, and profit, which is y. So in other words, we need to find our vertex. Okay, and since it's in standard form, we're going to use our values of a, b, and c to calculate our vertex. So remember that h in this form is the opposite of b over 2a. So the opposite of b would be negative 600 over 2 times a, which is negative 15. So simplifying the bottom, we get negative 30. And when we divide this, we end up getting positive 20. So we now know that the h value, or x coordinate, is 20. Okay, so in fact, that is the price that will yield the maximum profit. So in fact, we've actually already answered the first question. What is the ticket price that should yield maximum profit? $20. The second part, though, says, well, what is the maximum profit? Okay, so now we basically need to find y here, or k. So remember that to find k, we need to take our function and plug in the value we got for h. So plug in 20. So we're going to have negative 15 times x squared, or 20 squared, plus 600 times x, 600 times 20, plus 60. Okay, so some math to do here. 20 times 20 is 400 for our exponent, plus 600 times 20 plus 60. Multiplying here, negative 15 times 400 is negative 6,000. 600 times 20 should be 12,000 plus 60. Negative 6,000 and 12,000 is 6,000, plus our 60 gives us $6,060. So our maximum profit, so we have a maximum profit of $6,060 when the ticket price is $20. All right, so there's a nice word problem that has to do with our parabolas, maximizing a function that we can find with a quadratic. Maximizing or minimizing is actually used in business a lot. So there's lots of similar questions like these. So thank you guys that stuck around for the whole thing. That's a lot of notes for today, but it's all pretty important and will definitely help us out as we visualize what we do as we work with quadratics.